Okay, so those formulas for magnesium oxide were not the correct formula for magnesium oxide, but they were the correct answer for those problems. So something went wrong in the experiment. What went wrong? Okay, now I had magnesium like this, but it should have been magnesium like this. You know that because magnesium is 2 plus, oxygen is 2 minus. If you don't know why oxygen is 2 minus, then please send me email and I will explain it to you. So it should be this, but it was this. What's wrong? The O is too large. The O should be 1. Okay? So, what could have happened? There was unreacted magnesium? No, because if you have some unreacted magnesium strip in here, then that did not get the oxygen gas combined with it. That means not enough oxygen came inside the crucible. That means you have a lower mass, not a higher mass. You didn't have enough matter inside here because you were missing some oxygen. So it's not that one. Magnesium nitride. Okay, now remember, magnesium nitride is this. This is heavier than magnesium oxide, but as Mike pointed out on the day we did this lab, although this is heavier than this, look, there are 3 magnesiums here. If you formed this, then you would have formed fewer molecules. So the total mass of all of the Mg3N2 would be lower than the total mass of all of the MgO. Because there are 3 Mgs in here. So let's say you only had 6 Mg atoms inside the crucible. You would have made 2 of these. You would have made 6 of these. So what would be lighter? This would be lighter. So this is not the answer. Magnesium nitride means that your crucible would be lighter, not heavier. Your O would be a lower number, not a higher number. Some water? Yes. If you had still water inside the crucible and then you weighed it on the balance, what would the balance tell you? It would tell you the bigger mass, right? Because of the water. So then you write down the bigger mass and you think that there's no water, and then you think that that big mass all came from oxygen coming in. You think that, oh, that extra mass is all due to oxygen, and then that's why you have a big number here, because you thought a lot of oxygen came in, but that was not true. So this is the correct answer. Some magnesium oxide flew out. Okay, when you're doing the experiment, if magnesium oxide flies out because it's so hot, it pops. When you put water in here, the water boils too violently and it pops. So you're losing mass. If you lose mass, you're going to think that you had less magnesium oxide in here. Or you're going to think you had less oxygen gas. You're going to think you had less oxygen gas coming in because you lost mass. That's going to make this number lower, not higher. So it's not this one. Okay? I can explain that to you more slowly. If you want, just send me email or call me, and I'll set that up for you. Okay? Blah, 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 blah. Okay, this is a titration. The pink color comes from phenolphthalein. It's right here, phenolphthalein. You would know that if you read this problem and you see that, then you would know that this is responsible for the pink, because you know from your everyday life, and if you were in the lab that day, you know from the lab that the vinegar doesn't change color. You have to put something in it to make it change color. Okay. Blah, 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 blah. What is it? Okay, so remember, the chemical equation is this. Okay, so this is the chemical equation. Oh, sorry. It's already balanced. Okay. So because this is the balanced chemical equation, and there's no number here, and there's no number here, that means there's really just a number 1 there, doesn't it? So that means for every 1 mole of sodium hydroxide you use, you're going to need you're going to react with 1 mole of acetic acid. This is acetic acid, this is sodium hydroxide. So keep that in your mind, okay? 21.05. What is the concentration? Okay, now we're looking for the concentration of acetic acid. Concentration is moles per liter. So concentration, that's molar, and that equals moles per liter. Okay? So, acetic acid, the concentration of acetic acid. We want moles over liters. So let's start with the sodium hydroxide. Here it is. Here is the sodium hydroxide solution. It was 0.10000 moles per liter, molar. 0.1000 molar, which is moles sodium hydroxide in 1 liter. Okay? How many liters did we use? 21.05, but that's milliliters. So in 1 liter, there are 1,000 milliliters. And we use 21.05 milliliters. Okay? This tells us the moles. This is the moles of sodium hydroxide. Why do we want that? Because you want the moles of acetic acid over the liters. So the moles of sodium hydroxide are connected to the moles of acetic acid in this chemical equation. I'll show you. So this is 0.1 over 1,000 times this. So this is 2.105 times 10 to the minus 5 moles of NaOH. Oh, sorry, 10 to the minus 4. Okay, so now let's take that number, 21.05 times 10 times 10 to the minus 4 moles of NaOH. And let's see what we can get from acetic acid with this. Now I put moles of NaOH on the bottom so they can cancel. Now in here, 1 mole of NaOH goes with 1 mole of acetic acid. So 1 mole of this, 1 mole of acetic acid. That's a 1, not a 7, okay? Okay? Remember, this comes from this. Alright, that's where it comes from. That's how you do it. So that means the answer is I have 2, oops, this should have been a 1, this should have been a dot. Okay, the answer is I have 2.105 times 10 to the minus 4 moles of acetic acid. Okay? Now, they want the concentration, so that's moles per liter. Now, how much acetic acid did you use? How much vinegar solution did you use? In your lab, you used 5.00 milliliters, and I forgot to write that in here, so I'm sorry. You must have had much trouble doing this problem, because I forgot to give you the fact that it was 5.00 milliliters of vinegar solution. Yes. I will be sure to include that necessary information on the final exam. Okay, so since I know this, I'm sorry that you didn't know that, but since I know this, I can do the problem. First, I'll change this to liters. This is 0.00500 liters. So now the concentration is molar, moles per liter. Moles divided by liters. Here's the moles. Divide this by the liters. 3 significant figures. This is an L. Okay? .105 to the power of, no, times 10 to the power of, where is it? Where's my EXP key? Oh, here it is. -4. -4. Okay? Divided by 0.005. That's 0.0421. So that's 3 significant figures, 0.0421 molar. That's the concentration of the acetic acid. Okay? Very, very tough problem. I'm tempted to put 2 of these on there. Maybe not. Okay. 11.0. Then what is the sorry, this problem. If the concentration of H2O plus ions is 0.001 molar, what is the pH? Well, this means 1 times 10 to the minus 3 molar. And the pH is this, so the pH equals 3. What about this one? The pH 11, what is concentration of H3O plus? pH 11 means that the H3O plus, or the H plus, is equal to 1 times 10 to the minus 11 molar, because this is 11, okay? Concentration of HCl in your stomach is 0.01 molar. What is the pH? Okay, HCl is a strong acid. So HCl breaks up into this and this completely in water. So if the concentration of this is 0.01 molar, there's no number here. That means it's 1. There's no number here. There's no number there. That means that's 1. So that means this is also 0.01 molar. If this is gone because it made this and this, that means this must be 0.01 and this must be 0.01. But we only care about this. Now, 0.01 molar is 1 times 10 to the minus 2 molar. And so, if that's the H plus concentration, or the H3O plus concentration, remember from class, H3O plus and H plus are really the same thing. You just need that. Okay? pH. P means negative log, or the power. Negative power, really, for the H. OH minus ions. What is this concentration? 1 times 10 to the minus 1, 2, 3, 4, 5. To the minus 5 molar. What is the POH? The POH is the power of the OH right there, 5. And what is the pH? Remember that the pH plus the POH equals 14. So the pH equals 9. I almost said 8 because you're smarter than me. Okay, anyways, pH is 9. Okay? That's it. Finally done. OMG. Hey, you know, it's been great having you in class. It was fun, especially when we were allowed to do the lecture demonstrations. Yeah. So, yeah, thank you very much for being very patient and a very nice class. Study hard.